So we're going to factor by grouping in these problems, and so what we can do is we can group the first two terms and group the second two terms and then factor out what we can. So what we're going to have is r times n plus 5n plus a negative r minus 5 as our second polynomial. So now what can we factor out of this first polynomial? We can factor out the n. So let's do that. We'll have n parentheses r plus 5. Because if we factor out an n from the first term, we're left with r. If we factor out an n from the second term, we're left with 5. And from the second term, we can factor out a negative 1. Right? So let's go ahead and do that. We're factoring out the negative 1. I'm just going to put a minus sign there. And I'll say parentheses r plus 5. So now that we have this, what we can do is we can use distributive property to rewrite this equation as n minus 1 times r plus 5, since we have both of them here and here. So this is going to become n minus 1 as one of the factors, and we're going to multiply that by r times 5. And why does this work? It's because this expression here is the same as n times r plus n times 5, right? That's what we have right here. And this second side is the same as negative 1 times r and negative 1 times 5, right? So that's what's happening here. It's negative 1 distribute out times r and times 5. So these two expressions are equal, and this is our answer. Alright, let's go ahead and do the same over here. So we're going to have 3np minus 15p as our first polynomial. We're going to group those together. And then we're going to do a plus a negative 4n minus 20. Group those two together and make two polynomials. So what can we factor out of the first polynomial? We could factor out a 3, right? 3 is the greatest common factor between 3 and 15. And we can also factor out a p. So we're going to factor out a 3p. And if we factor out 3 and p from the first term, we're left with n. If we factor out a 3 and a p from the second term, we're left with negative 5. From this term, this polynomial here, we can factor out a negative 4. All right, because negative 4 is a factor of 4, negative 4, and a negative 4 is a factor of negative 20. So I'm going to factor out negative 4, and that's going to leave me with a positive n and a positive 5. Right. We can always double check our work by distributing out. It's negative times positive is negative 4n. Negative times a positive is negative 20, right? So this works. And so using the distributive property, we can go ahead and say 3p minus 4 times the polynomial n plus 5. So we're factoring out 3p. That's going to be n. Oh, I'm sorry. This is a mistake here. This should have been a plus sign right there. That was confusing me. So anyhow, so now using the distributive property, we could say 3p minus 4 times n plus 5. So what do we have? We have 3p minus 4 in parentheses times n plus 5. Right? And we could always double check our work. 3p we're distributing out. We're foiling. So 3p times n is the same here as 3t times n. And 3p times 5, we have it there. And then we have negative 4 times n. We have negative 4 times n. And we have negative 4 times 5. Negative 4 times 5. Right? So these two expressions are equivalent. And this is how we are able to factor by grouping. So I'm going to put a box around that one as well.